Okay, this worksheet or this video is for worksheet assignment sheet number 8, section 4.5, and there is only there's two types of questions here, but only one section. Okay, so you see problems 1 through 10 on that page, and that's all there is for this. So what I want to do is I have 1 through 6 are referring to polynomial inequalities, and 7 through 10 are rational inequalities. So I want you to look at a couple examples out of each one of these sections so that you can come back and finish some of these yourself. Okay, so the first problem that I want to look at is number 4. We did a little bit with this involving inequalities of quadratics. Here they're going to approach some inequalities for higher order than a quadratic. Some of them are quadratics still, though. Okay, so I want to know for what values of x, okay, is the quantity 2 times 2x squared minus 3x end of quantity greater than -9. Okay, now here's what I need to do with that. The first thing you want to do is you want to create a polynomial where left side, right side, either one is a 0. Okay, so I need to move some terms around to get a 0 over there. So I'm going to distribute first. This becomes 4x squared minus 6x is greater than -9. And then I'm going to add the 9 over so that 4x squared minus 6x plus 9 is greater than 0. Okay. Next step, I need to solve that. Now you could use the quadratic formula. Okay, I think this is also going to be factorable by the AC method. So let me see. I don't know. It doesn't appear to be factorable. So let's use the quadratic formula. So if I know that x equals, I'm going to plug in -6 for my b value. A is 4, C is 9, and then for 2a on the bottom, that's going to be 2 times 4. So I've got 6 plus or minus the square root of so 36 minus 144. Okay. This may not be a real good problem to actually start off with, but either way, it's going to show one of the special um, kinds of problems that can occur because here's what's going to happen. You're left with negative underneath the radical. Okay, so when I go This is negative 108. Okay. Since the radical is negative, okay, that means that there are no real solutions to this quadratic. Okay. Now, what that means in terms of a quadratic is if you were sketching it, okay, this quadratic does not cross the x-axis. Okay. Because A is positive, I know it has to open up. So you get a graph of a quadratic that's going to do something like this above the x-axis. Okay, so what we've got to do is basically test a number, and one of two things happens. Either everything works or nothing works. And that's ultimately what's going to happen here. Okay, so so if I choose to pick a number, okay, so for example, test the number 0. When you plug in a 0, you end up with 0 minus 0 plus 9, which is 9. And 9 is greater than 0, like the inequality says. So 0 works. We get a yes out of that. So if 0 works, okay, then all of the numbers work. So my solution here is from negative infinity to positive infinity, all real numbers. No matter what number you would plug in, positive, negative, 0, okay, you're going to get an answer that's going to be true. Okay, and so all the y values or all the x values will work. Now, again, where we're looking for solutions is if the graph, for some reason, would not or would cross the x-axis. So, for example, we get something like this, okay, then what we want to know is, where is the graph going to be positive? Where is the graph going to be negative at? Okay, and that's what these points, these zeros, are going to tell us, okay, is what those values are. Okay, so that, again, that's kind of an extreme case. Okay, let me go back to something a little bit simpler. And then we'll see what more of what these problems are supposed to look like. So number 5. Okay, so number 5 says x plus 1 times x plus 2 times x plus 3. Okay, now this one has been factored for us, which is perfect. Okay, it means that we just saved us a lot of work. This is a cubic equation that's been raised to the 3rd power if you were to multiply it all out, but it's been broken up for us. So I'm going to take each one of these and set them equal to 0. I want to find the x-intercepts. Okay, so that means that x equals -1, -2, and -3. The graph crosses at those 3 spots. Now, those are pretty close together. That's what makes this a difficult problem, is that all three of those are pretty close together, okay? But either way, what I want to do now is, now that I have intercepts, I want to know what happens in between and beyond those. So this is where we make up the table. And in this table, I create intervals using these numbers. So clear out here to the left is negative infinity. And as I come in closer and closer and closer, I get to negative 3. And then negative 3 goes to negative 2. Negative 2 goes to negative 1. And then negative 1 goes to positive infinity. Okay? Now, also with these problems, I have to be aware of, is this graph going to be a dotted line or a solid line? So if I go back and look up here at the equation, this equal sign underneath here means that the line of the graph is actually included as a solution. So that means I have a solid line for the graph. That means all of these have to be brackets. Now, pick a number in each one of these intervals. In these, I have to be very careful because I'm choosing, have to choose decimals, and I'm going to choose numbers that are more or less right in the middle. So hopefully they're a little bit easier to plug in. Okay, now remember, I'm looking for a sign out of these answers. Okay, I'm looking for a sign. So go back to your original. If I plug in negative 1 into each one of these quantities, watch what happens. There's a negative left over in the first quantity, a negative in the second, and a negative in the third. And when I multiply those three negatives together, I get a negative. My inequality says less than, so a negative is less than 0, so this is a yes. Okay, so numbers in this interval work. Okay, when I do the 2.5, I get a negative, and a positive, which gives me a plus. I don't want positives. When I plug in here the negative 1.5, then this is negative, positive, and positive, which is negative. Again, a yes. And then positive, 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 which is no. Okay, so we're testing the intervals, creating the intervals using the intercepts, okay, the zeros, finding those test points, plugging them in, find the sign of my final answer, and see if it matches up with what the inequality says. Now, what I'm looking for now is any interval that's a yes, okay, has to be included in my answer. So I'm going to go from negative infinity to negative 3, bracket, union, negative 2, negative 1. And those are the two yeses that we got up above. So that union of solution sets is your answer. Okay, that's more typical of the type of problem that you'll see up above. Okay, in 1, 2, and 3, and you'll see more later. Okay, on number 6, I want to set that one up with you here, and then I'll kind of let you finish it. Okay, on number 6, this is another one that you need to worry about factoring first. Okay, so with this problem, okay, I know that x to the third minus 2x to the second minus 3x is greater than 0. So the first thing I'm going to do here is see the greatest common factor of x. That leaves me with an x squared minus 2x minus 3, which is a quadratic. I can unfoil the quadratic into an x minus 3 and an x plus 1. And now I'm ready to use this zero product rule. So x equals 0, x minus 3 equals 0, x plus 1 equals 0. Now this is a little better problem because these zeros are spread out. So I should be able to, well, a little bit more. I still have to use one decimal, but either way, now I'm going to create my intervals from those. So I'm going to go from negative infinity. The first one, so this is x equals 3. This is x equals negative 1. So I'm going to go from negative infinity to negative 1, from negative 1 to 0, from 0 to 3, and from 3 to positive infinity. Okay? Now, again, you can start out by putting your parentheses on the infinities, but in this case, I have a greater than sign. Okay, so that means that the graph is not included, and that means that all of these are going to be parentheses. So I'm going to pick my test numbers. And again, I would plug them into this so that you can look at the signs. When you plug in a -2, you have a negative out in front. Plug in a -2 there, and you get a negative. Plug in a -2 there, and you get a negative. Okay. Now this time, I don't want negatives. So that's a no. Okay. Do the second one. Okay. Plug in 0.5. This is negative, negative, and positive, which is positive, which is yes. And then go from there. Okay. You should be able to plug in the 1 and the 4. The one thing that you'll notice about polynomial inequalities is that these values will alternate. No, yes, probably going to get a no and then a yes for the remaining two. In a polynomial inequality, those yes and no's will alternate. Okay, not necessarily true on the last two, the rational ones. Okay, now, so what do we do? The last two problems here, 9 and 10, those are rational because they have fractions. So how do we treat those differently? Okay, well, number 9, let's start with that one. On number 9, that we're going to looking for more than intercepts. Okay, so the numerator is going to tell us where the intercepts are. The denominator is going to tell me where there might be exceptions. Okay. In the previous worksheet, we talked about how to find the exceptions or the asymptotes, vertical asymptotes. Okay, those are places where these graphs will not go. So let's say, for example, because you get all sorts of weird graphs when you start dealing with rationals. Okay, so I need to be able to express not only where it's positive and where it's negative, but where the graph goes, period. Okay, so on number 9, what I'm going to do is I'm going to take each part of this fraction and I'm going to set it equal to 0. Okay, take each part, set it equal to 0. When I set the top equal to 0, I get that x equals -5. Okay, so that is one that is my intercept. Okay, that is my 0 for this particular function. Okay, now when I set the bottom equal to 0, this time if you use the square root method, you get x squared equals 4. You square root both sides. You get x equals plus or minus 2. Okay, those are your, I guess I'll just say your exceptions to your domain. Now, it's the combination of zeros and exceptions that create your critical numbers. And when we did the polynomial ones on the top of the page, all we had to worry about were zeros. That's all there was. Okay? Well, in rational inequalities, you have to worry about not only zeros, but exceptions. So you put the pool together, you create a list of critical numbers, and then you use the critical numbers to generate your table. Okay? So my table in this case is going to kind of look like this. So I'm going to go from negative infinity to negative 5, negative 5 to negative 2, negative 2 to positive 2, and positive 2 to positive infinity. Now, this is also got an equal sign up here in the rational expression, but the equal sign, it only affects the zeros. So because of the equal sign, the 0 that we found was at negative 5. I'm going to put a bracket on negative 5, but that's all. Okay? The exceptions that we find are always surrounded with parentheses. You cannot include an exception as part of your solution. So parenthesis, parenthesis. Okay, so there is your table. Move it up where you can see it. Okay, there's your table. Now, I'm going to test those one at a time. So I get my test numbers first here. Okay, and again, I'm concerned about the sign. So when I take the negative 6 and plug it in, okay, on top, negative 6 plus 5 is negative 1, but negative 1 squared is positive. So I get a positive on top. When I plug in the square down below, okay, x squared minus 4, that's also going to be positive. Okay, and so this is equal to positive. Positive is what I'm looking for, so that's a yeah. Okay, when I plug in negative 3, negative 3 gives me positive over positive. Still yes. 0 will give me a positive on top, but 0 minus 4 is negative 4, so I get a negative in the bottom. So there's a no. And then the number positive 3, we're back to positive over positive. So positive there. Okay. Now, so look at all of the yeses that I got. So that means I want to go from negative infinity to negative 5, bracket, union, bracket, 5 to negative 2, parenthesis, union, parenthesis, 2, positive infinity. Okay? Kind of a big solution set there. Okay, but here's the other thing that I wanted to note about this. Notice the first two quantities. Okay, because the -5 is shared by both of those, and because they are both shared with brackets, there is no break in that interval. So we can actually put those two intervals together and call that -infinity to -2, and then +2 to +infinity. Okay, so there's the simplest way you could actually write that. Okay, but again, the process is similar. We just have to be careful because of those exceptions that we're adding to the critical numbers. Okay, when we do the division, be careful. Okay, so number 10. There's your answer there, number 10. Okay, x plus 7 over x is less than 7. Okay, now with this problem, a couple things here. The first thing I need to do is I need to move that 7 over so that it's with the rest of the terms. So I'm going to subtract it over. Kind of looks like this. The next thing I need to do is I need to make that into one single rational expression. So I got these two terms here, and then I've got this real rational term. I want to put all that together using a common denominator, okay, into one single fraction. So I'm going to multiply this first term by x over x, and this last term by x over x. And this thing becomes x squared over x plus 7 over x minus 7x over x. And now, since they all have the same denominator, I can put it all together. And I'm going to rearrange some terms on top here, but I get x squared minus 7x plus 7 over x less than 0. Okay? Now, I'm looking at the top part of that. The top isn't going to, would have been nice if I got something that was factorable for you, but I didn't. So I'm thinking quadratic formula again to see what that does. So plugging in the -7. Okay, so that's what it looks like when you plug into the quadratic formula. -7 plus or minus. Actually, that should be a +7, sorry, because I want to take the opposite of b. Okay, 49 minus 28. And so it looks like 7 plus or minus the square root of 21 over 2. Okay. So from that, I'm going to create my intervals. And set up my table. So -infinity Now, what I'm going to do is to get to do the plus and minus on my square root, okay, I'm going to use my calculator and get approximations. So 7 plus the square root of 21 divided by 2 is about 5.8, and then 7 minus is about 1.2. Okay, so but I also have to worry about my exception here of 0. When x is equal to 0, I've got a problem. So I'm going to go to 0. I'm going to go from 0 to 7 minus the square root of 21 over 2. I'm going to go 7 minus the square root of 21 over 2 to 7 plus the square root of 21 over 2. And then I'm going to go 7 plus square root of 21 over 2 to infinity. Okay, now, because of the less than, everything is parentheses. And I've picked my test numbers. Okay, now plugging those in one at a time. Again, I'm going to use my simplified form here, right from, I'm going to use this. Okay, so plugging in -1, when you plug it in on top, I end up with a positive on top and a negative on the bottom. Okay, that is equals negative. That is what I want. Okay, plugging in +1, I get a positive on top and a positive on the bottom. That won't work. Plugging in 2, I get a negative on top and a positive on the bottom. That's a yes, because that answer is negative. And then on the last one, yeah, it looks like I'm getting positive over positive, which again is a no. So in this example then, I would say that from negative infinity to 0 combined with seven minus the square root of 21 over 2 to 7 plus square root of 21 over 2. I apologize for the numbers. Okay. the steps are what's important here. Okay. And I know I don't have, and hoping that I didn't make a mistake up there early that created these bad numbers. But, you know, if I did, which is a possibility. It's not the numbers that created the problem, or it is numbers that created the problem. The process, it would have been easier if I would have had easier numbers, but the process would stay the same. Okay, so I'm asking you to try that on problems 7 and 8. Try to find the critical numbers, set those up in a table with your intervals, provide some test numbers, plug them in to see which ones work and which ones don't, and then plug them together. Be careful about brackets and parentheses. That's probably the biggest thing, is be careful about those in the process. But other than that, that should help you finish section 4.5. And we'll move on to 4.6 here soon. Thank you.